Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, let's explore why and how to migrate your existing feast instance from Redis to DragonflyDB. If you are into MLOps or if you're someone who is interested in MLOps, I would highly recommend you to watch this video till the end because in this video, I will share my real life use case working with a client where we achieved significant performance improvement both in terms of model inference as well as model performance. So make sure you watch this video till the end. Let's get started. Cool. So sometime back, I was working with one of my clients where we were building a machine learning platform. The scope of the platform is very simple. Platform would host bunch of machine learning models related to fraud detection. And these models goal is to serve predictions online. So just like everyone, we also started with the training phase. During the training phase, we wrote some scripts that would query our data warehouse and fetch features according to our requirement or extract the features according to our requirement. So data warehouse stored historical data of the transactions of the user. Now using these features and our in-house machine learning algorithm, we started training the models. Parallelly, we were also running evaluation on the efficiency of the model. It took us some time to reach the desired efficiency with these models. But as soon as we reached the desired efficiency, we decided to scale this platform and ship the platform to production. Technically, we decided to move from training phase to serving phase. But as soon as we moved to the serving phase, that is during model inference, when it started dealing with real-time transactions of the user, we realized the efficiency of the models went down. And this is because of training-serving skew. If you're new to MLOps and if you're not sure what is training-serving skew, let me make it simple. It's a very, very common phenomenon where efficiency of the models goes down during the serving phase. Now, why does this happen? Let's take a simple example. Imagine you are dealing with a model. So this model would predict if a transaction of a user is genuine or fraudulent. In the training phase, you have the historical data stored in a data warehouse. You write some script to extract the feature according to your requirement, one or multiple features. Let's say you extracted a feature that has the current timestamp and last 24 hours transaction of a particular user. You started training model on this particular feature, and after multiple trainings or once you run multiple pipelines on the training run, within a month, you achieved 90% efficiency at the training phase. That is 9 out of 10 times. Your model can predict right if a transaction is genuine or fraudulent. You are happy with this, so you decided to move to the serving phase. But in serving phase, you deal with real-time transactions of the user. So let's say there is a transaction from X user and you want to predict if this transaction is genuine or fraudulent. Again, you would need feature, right? But this time you will not be extracting the feature from data warehouse, but you would extract the feature from a database or in-memory data store. It is much better if you go for in-memory data store because you can make an API call and you can fetch the feature much faster. And when you're dealing with real-time transaction, this is very, very key. That is the performance, how fast you can get the feature information from the data store. Now using this feature and using the transaction of the user, With the model that is trained, you will predict if a transaction is genuine or fraudulent. Now the catch here, because you are writing a query here and you are making an API call in this case, that can be a reason why your feature might not look the same as a feature that looked in the training phase. There might be new fields, or you might get more information in the feature, less information in the feature. And because of this feature inconsistency, the model's prediction usually goes down. Because here you are writing a query to your data warehouse, whereas here you are making an API call, or maybe you are writing a query to fetch the information from your data store. This is not standardized. Because of that, the feature can be inconsistent in your training phase as well as in your serving phase. And if the feature is inconsistent, the model efficiency will go down. How do you fix this? Right? There are two problems that we discussed here. One, how do you maintain feature consistency in the training phase and serving phase? Two, how do you ensure the performance of the model along with efficiency is maintained? Your model can be efficient, but if your model takes, let's say, 1 hour to predict if a transaction is genuine or fraudulent, it might be too late for your end user. So if you can extract the feature very fast, and if your model can compute that fast, then you can reduce this time from 1 hour to maybe a minute, or you can reduce the time from 2 minutes to maybe some milliseconds of time. So how do you solve both of these problems? So you can solve these problems if you go with a feature store. In our case, we choose a feature store that is Feast. Feast is a complete open source and it is also horizontally scalable. So even if you scale your platform or your model, you can still continue to use Feast. How Feast solves these problems? Number one, when it comes to feature consistency, Feast allows engineers to define the features in a Feast file, and this becomes single source of truth for both model training as well as model serving. So feature remains consistent because the feature is maintained, or the definition is maintained as a single source of truth in the Feast file. Now what Feast does along with that, it also introduces an online store and offline store. Understand this carefully. So when it comes to the offline store, so Feast connects with your data warehouse. Let's say, for example, DuckDB, which is a popular choice. So within the offline store, that is during the training phase, Feast connects with DuckDB with its offline store. And when you're looking for features during the training phase, according to the feature definition, Feast connects with DuckDB and extracts the feature so that you can start training your model. In the same way, when you are dealing with the online phase, Feast connects with your DragonflyDB or maybe Redis, and it extracts the feature information according to the feature definition. Along with that, Feast also does materialization, where it can also copy information from your offline store to the online store, right? But the main thing here is that one, Feast allows engineers to define the definition of the feature within the Feast file so that it remains a single source of truth. Number two, Feast can help you with the extraction according to the feature definition. So when it comes to the offline store, it connects with your data warehouse. During your training phase, you can ask Feast to provide the feature. It extracts the feature from the DuckDB or anything that you use for your data warehouse according to the feature definition and returns the feature information to your training phase. Similarly, Feast connects with DragonflyDB or Redis within its online store. And when you're trying to perform a real-time prediction, it extracts the information from DragonflyDB or Redis. Now, in our case, because we were new to this and we followed the lot of common sources that are available in the internet, we went with a solution that is Redis. So we choose Redis for our online store. Definitely it was good initially. Now, when we were with limited number of customers and when we were dealing with very few transactions, maybe in some hundreds or thousands, Redis performed very well. The throughput was also good for the initial few users or limited number of transactions. But as we started onboarding new customers, as we started scaling up our platform, we realized this became a bottleneck for our feature store. From a single Redis instance, we had to move to a Redis cluster, right? So we had to set up an entire Redis cluster and we had to connect that to the Feast feature store. Now, even then the problem is not solved because Redis comes with a single threaded architecture, because of which when you're dealing with multiple transactions, again, it becomes a bottleneck because you have, let's say, 1,000 transactions to deal with, and you have a 3-node Redis cluster with limited CPU architecture. It cannot compute all these transactions. It takes a lot of time, right? So because of that, it became a bottleneck as well. So what we decided is to implement sharding. We implemented sharding. We also horizontally scaled and added new Redis members to the cluster, but still, it could not completely utilize the resources. So the CPU utilization or memory utilization was not to the fullest. So we had to look for an alternative considering all these problems, and we decided to move to DragonflyDB, right? Because our engineering team was spending a lot of time just maintaining the Redis cluster and managing this Redis environment. Instead, we went with DragonflyDB, which is a drop-in Redis replacement. So we did not have to change code. We did not have to make changes to the API. Even the CLI that we were using to connect to Redis was actually working fine with DragonflyDB as well. And the best part here is that DragonflyDB is vertically scalable. So we just had to connect one instance of DragonflyDB and it could replace the entire Redis cluster. So one single DragonflyDB replaced our entire Redis cluster and maintenance become very easy because it is vertically scalable. All that we had to do is to scale it vertically or allow the DragonflyDB for auto scaling. More than that, DragonflyDB comes with several other advantages. One advantage, it comes with multi-threaded architecture. That means even if you have some thousands of transactions, your DragonflyDB instance can handle these transactions with its multi-threaded architecture. If you are able to compute, let's say 50 transactions with Redis, with DragonflyDB, you can actually do it 25 times more. This is our personal benchmark that we have noted. We were able to run 25 times more transaction with DragonflyDB instance. And this is with a single instance because it comes with multi-threaded architecture and the single instance is vertically scalable. DragonflyDB also helped with efficient resource utilization. So basically, with its new architecture, DragonflyDB consumes significantly less memory for the same data. So it is much advanced in terms of resource utilization. Also, it helps with caching efficiency. As I told you, it is vertically scalable. But a point to note, for some reason, at least from my personal experience, a single Dragonfly instance always helped me. But still, if you want to go with a clustering, DragonflyDB also supports that. So DragonflyDB has something called Swarm. Using its Swarm, you can also set up a cluster with DragonflyDB Cloud. Technically, this can take you up to unlimited capacity. But as I told you, I would repeat that for my use cases, not only in this particular use case, but also in the other use cases, a single instance of DragonflyDB always helped me. As I told you, it also comes with a modern design. So it's a, you can consider it's a modern architecture of in-memory data store when you compare it with Redis or any other legacy systems. So these are the reasons why we had to move from Redis to DragonflyDB, and this migration helped us a lot. One, it helped us with performance because now Feast can extract the features rapidly, and the performance or the time taken to predict has drastically come down. Number two, it is also easy to maintain DragonflyDB. You don't need clustering, you don't need sharding, you don't need multiple backups, but you need a single DragonflyDB instance that is vertically scalable. It also comes with multi-threaded architecture and other advantages that I just talked about. Perfect. So for the purpose of the demo, I prepared this GitHub repository, Feast with DragonflyDB. I made this repository public. So after watching the video, if any one of you are interested, you can head to this GitHub repository and give it a try. Don't worry, I'll make this demonstration extremely simple. I'll start with explaining the steps so that you understand what will be achieved through this demo. Then I'll walk you through the source code. Finally, I will show you demo in action. There are only two prerequisites for this demo. Number one, we will have Redis as well as DragonflyDB running as containers on the local host. And we will do that through this Docker Compose file. You don't have to create a new Compose file. It's part of this repository. When you run this Compose file, it creates a bridge network for Feast to connect with Redis or DragonflyDB, whatever we are using as online store at that point of time. It will start both Redis container as well as DragonflyDB container. If you don't want both of them to be running at the same time, you can just run one of these containers, or to compare the outputs, you can have both of them running. Other prerequisite is data. Because we are dealing with feature store, we need data. And for that, I have this generate sample data.py. When you run this generate sample data.py file, it generates sample data for 100 users. Using NumPy and pandas, it will serialize the data and it will save the data in parqueue file format. Perfect. Once we have both of these prerequisites, we can start with the actual demo part, where we will set up Feast with Redis as online store initially, because we want to understand migration. A lot of teams must be running Feast with Redis. So first, we will set up Feast with Redis as online store. We will materialize features to Redis. So we will basically run Feast apply. We will load the data to Redis online store, and we will also extract the data to verify Feast is rightly configured with Redis. Once we are confident about this, then we will head to migrating the setup to DragonflyDB. Remember, DragonflyDB is a drop-in Redis replacement. So you don't have to run a lot of commands, or you don't need a lot of steps for this migration. You can actually do it with minimalistic migration configuration. I'll show you that during the demo time. Finally, we will verify migration works seamlessly. How we will do this? So we will initially look at output from Redis as online store. Then once the migration is complete, we will compare that output with DragonflyDB as online store. If both the outputs are same, that means your migration is successful and there are no issues with your migration. Perfect. Now let me quickly walk you through the source code as well. You already know what is this Docker Compose file, and you already know what is part of generate sample data.py. Additionally, there is this requirements.txt file. If you are familiar with Python, this is a common file used to list out the dependencies. So we have Feast as dependency for this project, quite obviously. Then we have Redis client. if you observe this carefully, when we connect to Redis online store, we will use this Redis client. But post migration or during the time of migration, we can still use Redis client to connect with DragonflyDB as well. So this means you don't have to update your source code or you don't have to make changes from source code point of view because DragonflyDB is API compatible as well with Redis. We will use NumPy as well as pandas for serialization of sample data that we are generating. Additionally, there is this feature repo folder, very important folder from Feast point of view, because in this folder, you usually have feature definitions.py file, which defines features. So the feature store understands through this file what kind of features is it going to deal with. In our case, it is going to deal with total orders, total spend, as well as average order value. These are the three features that feature store or our online store is going to deal with. Perfect. Then in the feature repo folder, we also have feature store.yaml file. In our case, I created two different files. So when we will use Redis as online store, I will copy contents of this file and I'll call it feature store.yaml file. And when I use DragonflyDB as online store, I'll copy contents of this file and call it feature store dragonfly.yaml file. In fact, if you observe carefully, both of these files are absolutely same. Only difference is that because I'm running both Redis as well as DragonflyDB on the local host, I'm using port 6380 to map DragonflyDB container, and I'm using 6379 to map the Redis container to my local host. If I just have one of them running, I can use 6379 for both of these containers, that is for both Redis as well as DragonflyDB. So I don't even have to update this file. But I want to show you the output parallelly. So I have both of them running on different ports, or both of them map to different ports on my local host. Great. So this is about the feature repo. And finally, we have two files. One is demo redis.py. This file will take care of configuring Redis as feature store, online store. So what we'll do here, we'll first copy the contents of feature store redis.yaml to feature store.yaml, as I told you. Then we will run feast apply to apply feature definition to the registry. If you remember during the theory part, I mentioned defining the features is very important. We will do that using feast apply, and we will materialize the features. So basically we will load the features to the online store and verify by extracting the features or by fetching the features from the online store. Four simple steps. Step number one, define feature store.yaml. So we will do that using feature store underscore redis.yaml. Step number two, we will run feast apply to define the feature definitions to the registry. Step number three, we will materialize the features. Step number four, we will fetch the features to understand if Redis is configured as an online store. And finally, we have migrate to dragonfly.py file. Of course, we can carry this migration manually, but I would highly encourage to prepare such Python file or script file, because in your organization, you might be dealing with multiple feast environments, maybe lower environment, higher environment, production environment, or you might have different feast instances for teams. So if you have a script ready like this, you can just reuse the script across different teams and different environments. Now, during the migration, again, we will just run simple steps. Step number one, we will copy feature store dragonfly.yaml to feature store.yaml, right? And then we will rerun the feast apply to define feature definitions. We will run materialization so that we copy the contents to DragonflyDB. Finally, we will extract or fetch values from DragonflyDB, features from DragonflyDB to make sure they are exactly same as what as the output that we got from Redis. Perfect. Now let's start with the demo. I'll take my terminal. As first step, let's clone the repository. So I'll copy the repository URL. You can find this link in the description as well. Git clone followed by repository URL. Okay, switch the directory to feast. Whenever you're dealing with Python projects, make sure you set up virtual environment so that you don't run issues with respect to dependency conflicts. So for that, Python 3 -m, I'll call it as .venv. Okay, source .venv bin activate. Perfect. Now let's start with the first prerequisite. That is, let's run the containers. Make sure you're in the directory where you have the Docker Compose file. Docker Compose up -d. So it created the network for us. Then it started the Redis container and also it started the Dragonfly container. Make sure the Dragonfly container is in the healthy state. So when you run Docker PS, right now health status is starting, but after a few seconds, you should see the status as healthy. Only then move to the next step, because if your Dragonfly container is not healthy, towards the end of the demo, when you migrate your online store to DragonflyDB, you might run into issues. So I'll check it one more time. Perfect. So roughly after 30 to 40 seconds, the Dragonfly DB container status is healthy. Awesome. Now, what is the other prerequisite? Data. Python 3 generate sample data.py. Okay, so it says you haven't imported the dependencies. That's okay. So I'll just run pip3 install -r requirements.txt, where I have defined the dependencies for this project. Feast, Redis client, NumPy, pandas. These were the 4 dependencies. Okay, I think we're almost done. Now let's try it over. Python 3 generate sample data.py. Okay, this time I hope it will go through. And once it generates the sample data, we have seen the data is stored in ParQ file format. Great. So the data is ready with 3 features: total orders, total spent, and average order value. Great. These are the features that we want to deal with as well. Now we are done with the prerequisites. What is the next step? If you look at the README file, you can find them. We have installed the dependencies. We started the containers. We verified the containers are in ready state. We generated the sample data. Now let's configure Feast with Redis as online store. For that, Python 3 demo underscore redis.py. I just explained you a couple of minutes ago. When we run this, it should execute 4 steps. Number 1, right? It should run. It should use the feature store.yaml file with Redis configuration. Then it should run the feast apply. It should materialize the configuration or the features. And finally, it should extract the features. Perfect. So all the 4 steps are executed. Setting up feast with Redis configuration, applying the features. So defined, materializing the features. And this is the last one, extracting the features. Okay, these are the retrieved features. Let's store them so that we can compare them with DragonflyDB as online store. Now let's start with the migration process. For the migration process, I'll just run Python 3 migrate to dragonfly.py. Migrate to dragonfly.py. Great. Okay, so let's quickly see what happened. So migration just took place in seconds of time, even less than that. What exactly steps did it perform? Switching to Dragonfly configuration. So it basically made this configuration change using the feature store.yaml file. It changed from localhost 6379 to localhost 6380. Once again, if you stop the Redis container, you can access DragonflyDB on the same port. You don't even have to update that configuration. Step 2, it applied the feature definitions. Great. Materialize the features to DragonflyDB, and it extracted the values or features from DragonflyDB. The user IDs are 1, 5, and 10. Let's compare that with Redis. Great. It is same 1, 5, and 10. Average order values are 50, 444, and 415 with exact same decimals 50, 444, and 415. And total orders are 39, 8, and 11, which is exactly same in this case as well. This shows you can easily migrate your existing feast instance with Redis as online store to DragonflyDB and with very, very minimal changes. Now, what's important? You get performance advantages of DragonflyDB. At scale, DragonflyDB's modern architecture and multi-threaded architecture can perform much better than Redis. Additionally, you don't have the complexity of maintaining the Redis cluster. In this case, we just have a single Redis instance. But imagine when you are dealing with Redis cluster, you have to go with horizontal scaling as you keep adding more data. Whereas with DragonflyDB, it's super easy because DragonflyDB out of the box can perform vertical scaling. And you don't have to maintain a cluster of DragonflyDB in that case. You can just maintain a single instance with the same capabilities of Redis cluster. I'll share few important document links in the description so that you understand performance advantages of DragonflyDB even better. Make sure you go through them as well. Thank you so much for watching today's video. I hope you found them insightful. See you all in the next one. Take care.